In this lesson, we are going to be playing a game called Picking Blue. To begin with your warm-up, you'll write the fraction as a decimal rounded to the nearest hundredth. That means that you get 2 place values. The third decimal is going to tell you whether to round up or to stay. So to find the decimal, we can do 22 divided by 30. And so we have these 2 decimal spots that we get to use. The 3 here tells me it stays. If it is 5 or more in that third position, then we need to round up. If it is 4 or less, it will stay. So 0.73 is that fraction in decimal form rounded to the hundredths place. So the way this game is played is that you're going to draw chips or items out of a bag or a bucket, and you continue to earn points unless you pick red. If you draw a red, your turn is over. So as many blue chips in a row that you select from the bag or bucket is what your score will be. Here's some information about the setup of the game. In the Picking Blue game, you get to choose the bucket you use to play the game. So you can decide whether to use bucket A or bucket B. Each bucket has the same total number of chips, and inside the chips are either red or blue or red. One bucket has an unequal number of blue and red chips. The other bucket has an equal number of blue chips and red chips. What information do you need before you choose your bucket? You may want to know how many total chips there are. You may also want to know how many blue chips are in each bucket. You may wonder about the percentage of blue. So with the one that has the equal number of blue and red chips, you would know that it's 50% and 50% blue and red. But in the other bucket, it would be helpful to know what percentage are blue, so you can determine if it's greater than 50 or less than 50% for blue. This says, ask one group member to pull a chip from bucket A without looking in the bucket. Record the data in the table and place the chip back into the bucket. If needed, round the relative frequency to the nearest hundredth. Repeat the process until the table is complete. So we're going to take a sampling from bucket A to help us determine if we should select bucket A or bucket B when we're actually playing the game. This is an experimental part of the lesson where you're trying to determine, does bucket A have 50% blue and red, or does it not? So it should look something like this. Number of blue chips pulled so far. 1. Relative frequency. It's 1 out of the 1. Well, 1 divided by 1 is 1. 2. 2 out of the 2. 2 divided by 2 is 1. 3. 3 out of 3 is equal to 1. 4. 4 out of 4 equals 1. Still 4, because this one is red. 4 out of 5. 4 divided by 5 is 0.8. That is a fifth one. 5 out of 6. It does say here to round to the nearest hundredth if necessary. When you do 5 divided by 6, you get 0.83 repeating. Remember, hundredths, we keep 2 decimal spots. 3 is below 5, so it stays 0.83. This is red, so it's still only 5 blues so far. 5 out of 7. 5 divided by 7 is equal to 0.714. We're looking at these two place values. This is below 5, so it stays 7.1. There's the 6th blue. 6 divided by 8, which is equal to 0.75. Here we have still 6. 6 out of 9 is equal to 0.6 repeating. That third one, since it's 5 or more, it rounds this up. So instead of 66, it should say 67. And then this is still 6, since we haven't gotten another blue yet. So 6 out of 10. 6 divided by 10 is 0.6. We are now going to graph our relative frequencies here. So at 1, we had a frequency of 1, or relative frequency of 1. At 2, 1, 3, 1. 4 was still 1. And then at 5, we dropped down to 0.8. For the 6th one, it was 0.83. Then we have 0.71, 0.75, 0.67, and then 0.6. So you can see that it's starting to bounce around. After seeing 10 selected from the bag, do you think, or do you predict, that bag A is the one with the same amount of red and blue chips? Do you think that this one has 50% red and 50% blue? A bag with 50% red and blue should have a relative frequency of 0.5. That would be representing 50%. And you can see that as we pull more and more chips from the bag, we're approaching that 0.5 value. Your graph here may be different than the one that I did if you pulled your own chips from the bag and put your data here. And the reason for that is because they are chance experiments. Even if we all had the same bag, we aren't all going to select the same chip every single time. Here you can see what would happen if we selected 20 from bag A. 50? 140? So you can see that these are all hovering right around that half mark. Let's look at what would happen with bucket B. Ooh, the more and more, if they did 140 pools from bucket B, you can see that this one's starting to head towards about 0.35 or 0.3, between 0.3 and 0.4. So which bag do you think has the same amount of red and the same amount of blue? Which bucket would you want to use to play the game? Explain. I want to use bucket A because the estimate of the theoretical probability which was based off of the experiment, was greater in bucket A. The probability of selecting blue was greater in bucket A. And I'll go back and show you in just a second. A is in between 0.4 and 0.5. But B was between 0.3 and 0.4. So bucket A had a greater estimate. Here you can see those graphs. If they did over 900 pools, we did 10. If we repeated that process 900 times, you can see that the more and more times we repeat that experiment, the closer and closer it gets to the actual theoretical probability, the more accurate our answers become. So this one has a estimated probability of 0.5, whereas bucket B has an estimated probability of 0.3. So bucket A would be the bucket I would want to choose because selecting a blue has a greater probability of occurring. So here is what it looks like inside of bucket A and bucket B. So you can tell that you have a greater probability of selecting a blue from bucket A over bucket B. And you can see that the theoretical probability is 0.5 because it's half, and this one is 0.3 because it is 3 out of 10 chips altogether. Suppose you are filling a new bucket with chips for the game. Shade each chip either blue or red. So you get to decide how many to shade blue and how many to shade red. That looks almost purple. Let's try again. I've decided to shade 4 red and 6 blue. And then in part B, complete the table. How many chips are blue? How many chips are red? And how many total? There are 10 chips altogether. What is the theoretical probability of pulling a blue chip from your bucket? There are 6 blue out of 10. 6 divided by 10 is 0.6, or 60%. If you chose a different amount of blue and red, you'll have to use your results to calculate your answer in part C. Here is what their bucket was. They decided to put 8 blue. You can see that their theoretical probability is 8. So they put 8 blue and 2 red. And you can see when they selected items from the bucket, this is about 100, that it's starting to approach that theoretical probability. So it says, how can we use empirical probabilities to create a probability model? When we use a large number of trials, it helps us approach that theoretical probability. So we can use those results from repeated trials to help us approximate theoretical probabilities.